Hi, y'all there, folks. This is Algebra 1, Chapter 2, Section 8, Literal Equations and Dimensional Analysis. So stay tuned and strap yourselves in and let's do this. All right, so literal equations is basically a section that can cause some frustration, but I just want to try to help you, give you some pointers on how to alleviate some of that frustration. So basically what you're going to be seeing in these examples is that you'll have more than one variable, and that's hence what causes the frustration. Most people, they don't even want to see one variable, but they can deal with one variable. But in this case, we've got an m and an n. However, what you'll see in these examples is that they'll be asking us to focus on one of them. For example, in this case, they're asking us to solve for m. And that's probably the first thing you want to do as you start an example or a problem, is to identify what is the actual variable, because once they tell you that they want you to solve for m, then every other variable just becomes another number, at least as far as how we're going to treat it. So what I want to do is I'm going to rewrite the problem, but I'm going to highlight the m with red so that we can just keep in mind that m, not n, is the actual variable. So at this point, you solve the problem like you normally would. You treat 3n as a normal number. If that didn't say 3n, if it said 37, then all we would do is the opposite, which is add the 37. It's not 37, it's 3n. So we're going to do the opposite, which is to add 3n to both sides. That's going to leave you with 4m equal to 8 plus 3n. And this is where it gets tricky, because obviously if it was 37, we could just take 37 and add 8 to it and write our answer down. But we can't add numbers with letters, so we just leave it like that, 8 plus 3n. Our last step is, since this is 4 times m, we're going to divide by 4, and then that's going to cancel, and then we can say that m equals 8 plus 3n all divided by 4. It's important that you divide everything by 4, not just the 8. But also the 3. Okay, so another option for your answer could be, we know that 8 divided by 4 is 2, but then you also have to divide the n by 4, so then you get plus 3n over 4. That's another option for your answer. So that is how you do this. So we are going to let you have a shot at it. Again, remember that you want to identify in each problem what the variable actually is. So I'm going to help you out by just kind of, this says for n, so then n in red there becomes the variable. This one says for t, so t becomes the variable. Everything else is just another little number. We have over here for q, and then over here we have for k. In each situation, you want to remember what the actual variable is. Alrighty? Okay. So then we want to go on to this little guy, and this is a little bit even trickier than before. And I will tell you, the difference between this example and the previous example is that you have the variable on both sides. And you will recall that when we first started this chapter, we did problems that had variables only on one side, and then we went to the more complicated variables on both sides. And now we're complicating it even further by putting multiple variables. But again, one of the keys is going to be for you to rewrite the problem, and in this case, x is the variable. So anytime I see an x, I'm going to use my color coding here. And yes, it costs me a little more effort, but I think it's worth it. So I have x here in the 3x term, and I also have it in the xz term, okay? So that's my variable. Now you will remember that whenever you have variables on both sides, your goal is to get the variables on the same side. Okay, so what we want to do is we can first and foremost get rid of the 2y, take him to the other side, and then that'll give us 3x equal to xz plus 5 plus 2y. Again, there's no other y's on this side to combine the y's with. So here we go. Now our next goal is to get the x's on the same side. So you're going to want to subtract xz from both sides. Okay, so I hope that you're seeing there that despite the fact that it can seem scary, I'm not doing anything really new. I'm just doing the opposite of what's being, this is a positive xz. So I'm going to subtract xz to both sides. And now what I'm going to have is 3 x, and then we're going to go minus x c. Like that, 3x minus xc. And on the right-hand side, we no longer have any x's. Okay, now right here I want to pause for a moment because I know that when you look at something like 5x plus 3x equals 16, for example, I'm pretty confident that all of you know that you can take 5x and 3x, and since they both have x, you can just take the 5, add it to the 3, and times it by x. Because 5 plus 3 is 8, and you get 8x. Now, most of the time, we skip this step. In our heads, we just do it in our head, and we say 5x plus 3x is 8x. But I want you to see how this works, is that we know that we take the coefficient of this x and the coefficient of that x, and we add them together, and then times it by x, and that's the same thing. That's how we get 8x. But we skip that step a lot of times, and so I don't want you to skip that step here. But that's exactly what we're going to do. We're going to take the coefficients that are attached to the x. So in this case, the 3, the minus, because it's not adding, it's subtracting in this case, and the z. The 3 and the minus and the z, and then we're going to put the x outside and multiply it. This is called factoring, okay? But again, the x comes out, and you just combine the two coefficients that are attached to the variable, just like we did over there, okay? And so then we continue. We still have 5 plus 2y. And now our last step, since this is x times 3 minus z, we're going to divide by 3 minus z on both sides. And lo and behold, our final answer is that x equals 5 plus 2y divided by 3 minus z. There's my answer. Okay, so this one gets a little bit trickier than the previous one because you have x's on both sides. But again, I just want to remind you that you need to put all the x's on one side, and when you get down to the very end, you want to take out the variable and combine the coefficients and then divide by that to get your final answer. All right, so you're going to have a chance to do that here with these two examples. And again, just want to remind you that in this case, we're going to use q as the variable. And over here we're going to have d, but there are 2 d's in that expression, and there are also 2 q's in this expression. All right, so good luck with that. And then we're going to go on to formulas. Formulas are a type of equation, of literal equation. And so here we have the formula for the circumference of a circle. If you didn't already know it, is c equals 2 pi r, so you can see there are 2 variables there, where c represents the circumference and r represents the radius. So I'm not crazy, but in part A they want us to take this formula, which is c equals 2 pi r, and they want us to solve the formula for r. So instead of it saying c equals, they want it to say r equals. Okay, so as you can see, this is actually not a really hard problem to do. I identified the r. There's only one r in the expression. That's the good news. But this is 2 times pi times r. So everything happening here on the right-hand side is multiplication. So to get rid of the 2, I have to divide by 2. To get rid of the pi, I have to divide by pi. And the same thing on the other side. Okay, so that means 2 divided by 2 is 1, pi divided by pi is 1. So that means that my answer will be r equals c divided by 2 pi. So I've done what they've asked for part A, and I don't want you to think that I'm crazy, but in part B it says find the radius of the yo-yo, and you're going, what yo-yo? Well, actually, I didn't want to write down the whole example, but in your book on page 127, right next to example 3, which is what I'm doing right now, to the left of it, there is a little picture insert there, and it says, the largest yo-yo in the world is 32.7 feet in circumference. And we just said earlier when we read this, that C represents circumference. So according to this, circumference is, of this particular yo-yo, is 32.7 feet. That's the circumference. It was launched by crane from a height of 189 feet. That's not really important, but what's important is the circumference part. Okay, because it asks us here, find the radius of the yo-yo. Now none of that makes more sense. See, I wasn't being crazy. I'm not using an imaginary yo-yo. It's in your book on page 127. Okay, so what we know is that we want to find the radius. And we have an equation here in part A that tells us that the radius is equal to the circumference divided by 2r. Divided by 2 pi. So all I have to do is come on over here and go r is equal to the circumference, which in this case is 32.7, and divide it by 2 pi to get my answer. So I'm going to get my little calculator over here, and 32.7 divided by, and I'm going to use parentheses on my calculator. I'm going to say 32.7 divided by parentheses 2 times pi, and I do want you to use the pi button on your calculator. Don't use 3.14. You'll get a more accurate answer if you use the pi button on your calculator. And so after that, we get that it's approximately 5.2043, blah, 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 blah. So approximately 5.2 feet for the radius. Alrighty? And that is how we do formulas. So you will have a chance to do that here. We're giving you a formula right there, telling you what all the variables mean. We want you to solve for W. Right here. Solve your formula for W. So we want the W right here. And then after you've done that, they give you some dimensions and they want you to find the width for this particular problem. All right? And then we have our last example. And this example is dealing with the second portion of what the title of the lesson was, which is dimensional analysis. Another way of thinking of dimensional analysis is when you convert units. That's another way of thinking of it. Okay, so that's what we're going to do right now. It says here, a 10K run is 10 kilometers. If 1 meter equals 1.094 yards, use dimensional analysis to find the length of the race in miles. Now, I do this a little differently than what the book does and even probably other teachers do, but I like to do everything in one fell swoop. So I'm going to show you how I do that. So first we have our 10K, so 10 kilometers, and we want to convert that. We want to convert the 10 kilometers, okay? So what's going to happen here is that I know that, and maybe you don't know this, but it's pretty common. 1,000 meters is equivalent to 1 kilometer, in case you didn't already know that. 1,000 meters is equal to 1 kilometer. So I'm trying to convert from kilometers to yards. And I have, to miles. Okay, and I know that I have miles and yards here. They gave me a hint, miles to yards. But I need to get from yards to meters, and then from meters to kilometers, so that you can see how there's lots of stuff going on here. So what we're going to do is we're going to say, since we know that there are 1 kilometer is equivalent to 1,000 meters. What's going to happen is that this is basically a fraction. Anything that's on top and bottom, this is a fraction. And instead of multiplying, one thing at a time, I just do it all at once. But I want to be very clear that anything across the top is multiplication, anything on the bottom is division. So a kilometer divided by a kilometer, they're going to cancel. Those units are going to cancel, and you're going to be left with meters. But I also don't want meters. I want miles eventually. So from there, we're going to go from meters to yards because we know this. So we're going to put 1 meter is equivalent to 1.094 yards. All right. So now my meters and my meters will cancel. And now I have yards. But I don't want yards, I want miles. So then my last step is to take the 1760 yards. And on top, I put 1 mile. So then here, the yards are going to cancel. I'm going to be left with miles, which is what I want. I want miles, okay? So now I think we can probably call this done. So again, I want to just be clear that You always want the units to be opposite, like one on top, one on the bottom, so that they can cancel. As you will see right now, these kilometers are going to cancel with this kilometer. This meter is going to cancel with that meter. These yards are going to cancel with those yards, and I'm going to be left with miles as my units. And that's what I want. I want to figure out what this race is in miles. Now, as far as the math involved, you are going to, remember, this is just fraction times a fraction times a fraction times a fraction. But the easier way to do it, we know that when we multiply fractions, we can multiply across all together. So we're going to go 10 times 1,000 times 1.094. So I'm taking all these values, 10 times 1,000, 1.094, times 1 if you want, but obviously times 1 is itself. And we're going to get 10,940 on top. Then we divide by everything on the bottom. So that's 1 times 1760. So 1 times 1 is 1, and 1 times 1760 is 1760. And of course, we have our miles. So our final answer will be the 10,940 divided by 1,760, and we get 6.216 miles. All right? So that is dimensional analysis for you. And so now we're going to give you a chance to do that with this. Now just keep in mind that in this case you're doing, I'm going to help you out here a little bit. For those of you that get all flabbergasted when you see a word problem. It says a car travels a distance of 100 feet per 2.8 seconds. Okay? So you have to convert two things. It wants to know the velocity of the car in miles per hour. So you have to convert the feet to miles, and you have to convert the seconds to hours. Okay? So I will remind you that 5,280 feet are in 1 mile. That might be important to know. And I think that all of you know that there are 60 seconds in 1 minute and 60 minutes in 1 hour. So you're going to have to convert not just the feet, but also the seconds. Convert the feet to miles and convert the seconds to hours. And again, you can do that by using a really long fraction expression here. All right, so once you've done this example, you will have completed your notes, for this lesson. And I will see you in class, and thank you for watching.